Hi, my name is Rishek, and we as a team represent Gevo. And we're here to talk to you about a new biofuel product called alcohol to synthetic paraffinic kerosene, also known as ATJ SPK. Fossil fuel emissions has become a major problem that will affect not only us but our future generations. According to an article in 2024 by the CSIRO, 90% of the carbon emission is due to the use of fossil fuels, and aviation alone contributes to 2.8% of the global net carbon emission. ATJ is a form of sustainable aviation fuel, also known as SAF, which is an alternative form to traditional fossil fuels. ATJ is created through a biochemical or thermochemical sugar and starch conversion to either isobutanol or ethanol. Trial results have shown that ATJ is within the standard specification for aviation turbine fuel and is ready to replace traditional petroleum fuel. This product is aimed towards airlines, air freight haulers, and private aviation companies that are looking to switch to SAF and reduce the company's carbon footprint. Some of the companies that are using this product are British Airways, having invested money into other companies developing ATJ. Gevo also has a partnership with an Australian energy company called Viva Energy, in an effort to bring more biofuels to Australia. Viva being one of the most prominent fuel companies in Australia, supplying exclusive, high-quality oil to Shell, and owning multiple airlines, including Qantas and Virgin. ATJ is a sugarcane-based biofuel and is more efficient and produces less emissions than maize-based alternatives. It is relatively cheap compared to other SAF products in the market and produces significantly less CO2 than fossil fuels. ATJ, under an ethical lens, we can see how it deals with sustainability issues through regenerative farming, as well as environmental concerns by researching the possibility of using 100% ATJ and tackling corporate and financial issues by forming partnerships with farmers. Overall, ATJ joins Gevo's lineup of other renewable biofuel products such as renewable gasoline, protein and high-value nutrition, renewable gas products to help combat global warming.
Hi, I'm Chaniru, and I'll be walking you through the process which Gevo took to bring their SAF to the market. Throughout my section of the presentation, I'll be attempting to give you a general idea of the research and development phases, marketing phases, and obstacles faced in the development cycle. While Caleb will help give you a better understanding as to why Gevo's ATJ SPK is an innovative and sustainable SAF, Gevo's research into optimizing every step in the production process involves decarbonizing and defossilizing the process of creating fuel and capturing carbon. This is achieved by following the Department of Energy Argand Greed model, a scientific model that is updated regularly and works to increase the carbon captured and observes the carbon intensity along the value chain. This system also ensures that captured carbon will also be distributed to farmers along this value chain. For context, the value chain is all the steps taken by a farmer towards developing their product. Gevo also introduced Verity, a company focused on analyzing the carbon intensity of a full carbon cycle, while also verifying and tracking data related to this carbon intensity. Verity is a subsidiary of Gevo Incorporated and has entered a joint development agreement with Southwest Iowa Renewable Energy, SIA, while also collaborating with Google Cloud. The main reason that Verity exists is that the feedstock used for SAF production must meet a specific set of conditions, mainly cost, scale, and carbon footprint. The feedstock must also be equipped for large-scale production via a sustainability profile. Verity's tracking and profiling systems have already shown results in the process of optimizing the carbon cycle within the feedstock, with real field-level results promising an approximated 31% reduction in carbon intensity within SAF production. Gevo has also engaged in multiple ad campaigns in order to advertise their product to the masses and target consumer base. A quick highlight would be 2 Alaska Airlines jets flying from Seattle to San Francisco and Washington using Gevo's ATJ, comprised of 20% biofuel made entirely of US-grown corn. Gevo has also sourced many relationships with companies such as Aegis-Spire, Farmers Edge, Earth Optics, while securing investors in the form of BlackRock, the Vanguard Group Incorporated, and Invesco Capital Management, and has further secured a federal grant agreement directly from the U.S. Department of Agriculture for Gevo's climate-smart farm-to-flight program. Gevo has enjoyed the limelight many times. Fuel sales agreements with Hawaiian Airlines, Qatar Airways, and Japan Airlines shows that with the coming tide of change in the aviation fuel industry, Gevo is a present and competitive name that focuses on environmental stability while facing industrial growth.
Hi, my name is Jerry, and in this section, I'll be covering the commercial viability of Gevo's SAF. I will be examining 5 components to assess Gevo's potential in the market. Looking at the big picture of Gevo's IP portfolio, in the present day, the company has been granted 1 patent for their unique process of conversion of ethanol to functionalized lower and downstream hydrocarbons, which is related to the production of their SAFs. And they have also filed 2 more patents on other processes that are beneficial to them. The company issues licenses for its butanol production technology to biofuel companies like Praj and Butamats, and also received a license to convert ethanol to general hydrocarbons by Exxon. Comparing Gevo to its competition in the market, Fulcrum Bioenergy, both companies apply different technologies in producing their SAFs. At present, Gevo has already gotten the approval for the American Society for Testing and Materials, ASTM, for the use of their SAFs commercially. The Fischer-Tropsch technology implemented by Fulcrum may have gotten the approval as well, but there are claims that their fuel production process has a high energy requirement and there are concerns in the protection of human health, so the path has been turbulent for them. Whereas Gevo has an efficient production line for their in-house biobutanol and other chemicals. As I have mentioned previously, Gevo has gotten the approval from ASTM and specific annexes to the standard applied to individual processes for producing alternative jet fuels, meaning it's safe for flights. In regards to ethical considerations, I will leave up to Daniel to present, but overall Gevo has addressed issues such as the sustainability and environmental aspects for producing the SAFs, and corporate matters such as the flight ticket differences between flying of fossil fuels and SAFs. The outlook for a product like a SAF will be that it is substantial in reducing carbon emissions due to the nature of the wide use of flying as a form of transportation. Gevo has signed contracts with airline companies like Finnair, Qantas, and many more to roll out the supply of SAFs by 2026 for the next 5 years. The current financial position of Gevo is then reflected on the delayed profits that they will receive from the SAFs. Biotech companies go through a valley of death in the early stages of development of a product, and Gevo is nearing the turning point of this spectrum, with the planned rollout of the SAFs to its signed contractors. Gevo has received grants from the government of Queensland and has signed a collaboration agreement with Viva Energy in 2020 to explore the potential use of renewable hydrocarbons, signifying the step into the Australian market. Having a look at Gevo's 2023 annual financial reports, although it may seem that they are constrained in their financial position now, looking at the numbers, note that the funding strains should be mitigated from Gevo's lineup, such as the bio-isobutanol, which is used by Coca-Cola to make plant-based PET plastic, and the renewable natural gas RNG, which has already been brought out to the market prior to the SAFs. Furthermore, regulatory initiatives such as the International Air Transport Association, IATA, have already approved the use of 50% mixed SAFs, and to a greater extent advocate the use for them for commercial airlines, and forcing on a switch to SAFs by 2050, with tripling goals along the way, such as a 65% reduction in carbon emissions. There is inherently a need for such technology to be further improved and implemented. To fulfill such need indicates a necessity to give attention to the progress of companies such as Gevo in smoothing out the production line of SAFs.
Hi, I'm Caleb. I'll be doing the value proposition. So IATA, of which represents 83% of total global air traffic, has recently introduced and committed all member airlines to achieving net zero carbon emissions from their operations by 2050, as mentioned previously. As part of the Fly Net Zero initiative, 65% of all contributions to this goal is expected to directly result from the use of sustainable air fuels. This, of course, includes Gevo's already commercially available product, ATJ SPK. So let me outline just what this means. For airlines not only wanting to comply with IATA's Net Fly Zero initiative, but show customers their active support in combating global warming, dissatisfied with conventional jet fuels due to high greenhouse gas emissions, Gevo offers a non-fossil based alternative jet fuel called ATJ SPK that achieves upwards of 75% greenhouse gas reduction over traditional petrol jet fuel. But wait, why use Gevo's ATJ SPK instead of other SAFs on the market? Well, SAFs in general face many issues throughout the production pipeline, some of which include
scalability of SAF production alongside keeping sustainability goals with low carbon emissions, economic transportation of the end product, and competitive pricing. So, here's how Gevo's ATJ SPK solves all these problems. For context, ATJ SPK uses fermentation to convert feedstock into either isobutanol or ethanol, which is processed again into a hydrocarbon mix, which is then blended into a fuel. In terms of scalability, not only can Gevo use fermentation infrastructure that already exists, they have partnered with numerous farmers and collaborators to both help spread sustainable farming and growing practices and develop production processes for other feedstock sources. Furthermore, Gevo's ATJ fuel already meets the American Society for Testing and Materials standards. This allows it to be blended into traditional petrojet fuel up to 50%, and once blended, this mix acts and behaves as traditional fuel, meaning any issues regarding use of existing transport infrastructure are negligible. Now, it must be admitted that any and all SAF production will cost approximately 2 to 7 times more than production of conventional jet fuels. However, what differentiates ATJ from other SAFs is that when sustainable corn is used as a feedstock, Gevo's refining process also produces, as a co-product, 10 pounds of high-protein animal feed for every gallon of fuel. This can then be sold to livestock farmers, easing the cost of ATJ SPK, with the benefit of contributing to healthier livestock due to more protein existing in the food chain. Furthermore, this increased production cost is expected to result in only a relatively small premium for customers.
Hello everyone, my name is Daniel and I'll be talking about the societal impacts of Gevo's sustainable biofuel. Having examined the commercial viability and value proposition of the aviation biofuel, we now evaluate its ethical and societal ramifications. To facilitate such an appraisal, we will first consider the specific legislative and ethical legal principles governing biotechnology production within Australia. These principles will serve as the foundation for later discourse on the political, economic and socio-cultural impacts of SAF. In accordance with the Australian National Framework of Ethical Principles, all biotechnological endeavours must be grounded in respect, justice, equity, probity and accountability. The Oz Biotech Code of Conduct further reinforces such principles through its emphasis on the balance between novel biotechnologies and the sovereignty of human rights and dignity. Such ethical principles are the grounding for the societal implications of SAF. Notably, the major societal impacts may be distinguished into sustainability concerns, environmental integrity, and corporate matters. Sustainability concerns are among the most salient vis-a-vis SAF production. They encompass issues such as the availability of food and water, arable land, and energy. As it stands, SAF biofuels are produced through sugar, starch, and maize fermentation, and these are food staples in many countries. Critically, Gevo aims to resolve this issue through its Farm to Flight program, which is grounded in agricultural practices such as soil analysis and profound respect for the environment. As for arable land concerns, they pertain to the encroachment of pristine lands, especially those in Lake Preston in South Dakota. However, Gevo hopes to circumvent such objections through its reliance on regenerative agriculture, which involves the reclaiming of infertile land and demonstrates accountability. As for environmental concerns, these include heat and greenhouse gas emissions as well as biodiversity issues. Notably, the production of sustainable aviation biofuel may involve the release of significant heat, carbon dioxide, and nitrogen oxide emissions. Gevo aims to resolve such issues through sustained research into the commercialization of 100% SAF flights, which may establish a precedent for the renewed potentiality of aviation biofuels. We now examine the corporate issues associated with SAF, and these include commercial production, consumer expenses, and fair trade. As it stands, although SAF has entered commercial manufacturing, its utility is circumscribed by scalability issues, which may limit the product's market share and prove an obstacle to smaller or medium-sized businesses. As for the consumer, the expenditure associated with commercial purchase of SAF may lead to an increase in airline fares, which may prove a hindrance for frequent travellers. Gevo hopes to avoid such a situation through the establishment of robust corporate government relations, such as those struck between Qantas and the Australian federal government, and these could foster a decline in commercialization costs. Moreover, it is also vital that Gevo addresses fair trade concerns, especially those pertaining to the liberties of farmers. To achieve this, Gevo hopes to establish holistic partnerships with its farmers, thereby allowing for a streamlining of aviation biofuel production and underscoring the company's dedication to respect and justice.
My name is Isam, and I'll sum up our discussion so far and talk about the impact of this technology on the broader biotech sector. Gevo SAF addresses the aviation industry's reliance on fossil fuels by transforming sugar and starch crops into eco friendly aviation fuels. The sugarcane based biofuel significantly reduces emissions and provides a cost effective solution for aviation industry. Gevo demonstrates a solid commitment to environmental sustainability throughout the SAF production process by utilizing the DOE Argon Grid model to ensure reductions in carbon emissions from beginning to end. The creation of Verity for rigorous carbon intensity tracking, alongside strategic partnerships with Google Cloud and Alaska Airlines, and support from significant investors and the US Department of Agriculture, positions the company as a leader in sustainable aviation fuel industry. The project also emphasizes ethical practices through regenerative farming and partnerships with farmers, underscoring a broader commitment to sustainability. SAF's alignment with global emission targets, reduction targets, scalability, and cost advantages over alternatives highlights its value. Moreover, addressing the ethical and societal impacts, including sustainability, environmental integrity, and corporate responsibility, showcases the holistic approach to SAF's development and market introduction. SAF technology advancements present exciting opportunities in Australia's biotech sector. Biotech companies specializing in biomass conversion, microbial engineering, and bioprocessing play a crucial role in optimizing feedstock utilization and boosting production efficiency. With the aviation industry aiming to ramp up SAF production to meet emission reduction targets, there is a need for genetically engineered crops with better yield and resilience. Biotech companies with expertise in agricultural biotechnology and genetic engineering can offer tailored solutions for sustainable feedstock production and optimization, thereby improving Australia's agri-tech sector. Gevo SAF can encourage policy support, investment, and collaboration between biotech companies, research institutions, and government agencies. Public private partnerships focused on biofuel research, technology transfer, and workforce training can speed innovation and lower SAF production costs. In conclusion, SAF is a promising alternative to traditional aviation fuels. Australia can adopt eco friendly aviation fuels through biotechnological innovation and collaboration, therefore, driving growth while also protecting the environment. Thank you for your attention and dedication to building a more sustainable world, and thank you for listening to our presentation.